Hello everyone, now we study about the normal form. Let A be an m by n matrix by a series of the elementary row and column transformation. It can be reduced to one of the following form. Is called a normal form, where IR represent the identity matrix of order R by R. The identity matrix means all the diagonal elements of the matrix is 1 and remaining all the elements are the 0. And the forms are IR means only the matrix is from the identity matrix. IR00 means one minor of the matrix form a identity matrix and remaining are the 0. Then we write this matrix in the form of the normal form. Then second, IR0 and IR0 means all the upper elements form the identity matrix and all the side of the element form the identity matrix. To transfer the given matrix in the normal form, these are the operation we perform. Elementary transformation means first we transfer any two row or any two columns, means IR converted into IJ or CI converted into CJ. Then second operation is instant multiply with row or the column, and third operation is RI plus minus KRJ or CI plus minus KCJ. These all the operation we understand with the help of the example. Some working rules to reduce given matrix to the normal form. First is, if A11 is not equal to 1, then interchange any two row or column suitable such that A11 become 1. 8. It is not possible. Divide the first row or first column by A11 so that A11 is. So in this rule we told that our first target is convert A11 into 1. So for that we have two conditions. First, we transfer means we interchange any two rows or interchange any two columns, so our targeted A11 is bring the 1. So for that we perform the operation interchange R1 with R2 or interchange C1 with C4, as you wish which operation you want to perform. If we perform R1 interchange with R2, then the matrix now R2 interchange with R1, so 1 2 3 4 2 4 5 1, and R3 remains as it is 3 5 6 7. And if we perform the operation C1 interchange with C4, then the matrix is C4 1 4 7, and remaining second column is as it is 4 2 5 5 3 6, and C4 is now 2 1 3. And another way, if you don't want to interchange any two row or any two column, then that time divided by the row or column with A11 itself. Means when we divide 2 with 2, then we automatically get 1. So divide 1 by 2 R1, so that time without interchange any two row or any two column, then we get 2 by 2 4 by 2 5 by 2 1 by 2, and remaining rows are as it is 1 2 3 4 3 5 6 7. which operation you want to perform is depends on you, but don't forget the target is that we convert the a11 into a 1. Now the second rule, by performing an operation of a type Ri plus Krj or Ci plus Kcj, bring 0 everywhere in a first row and first column except a11. Once the a11 convert into 1, then the second target is bring all the first row and first column is converted into a 0 by performing the row operation Ri plus Krj or the operation for the column Ci plus Kcj. Because we want to convert this matrix in the identity matrix whose only diagonal matrix are the 1, means 1 0 0 0 1 0 0 0 1, and remaining elements are the 0. So the third rule is repeat the above two steps on each of the remaining row and column, which means convert the given matrix into a identity matrix. For that again we target the second diagonal element. For converting the diagonal element into a 1 and remaining all the elements we want to convert it into a 0 by performing these operations, and at the end we want the identity matrix. These all rule we apply at the time of the problem solving. So some notes are there. First, the rank of the null matrix is a 0. Null matrix means all the elements of the matrix are the 0, and directly write the rank of the matrix is equal to 0. A is a non-singular matrix of order R, then the R of A is a R. A is a upper triangular matrix, then rank of A is number of a non-zero row. If the matrix is given in the upper triangular, then count the non-zero rows and write the rank of the matrix. So here 3 rows are the non-zero, so the rank of the matrix is 3. Non-singular matrix means when we solve the matrix, the answer is a non-zero. Then that time the order of the matrix is the rank of the matrix. Third note is A is a matrix of n by n order, then rank of A is always smaller than equal to mn. Means always rank is smaller than equal to mn. Here m is 3, n is 3. So the rank is always 3 or smaller than 3, but not greater than order, because we know the rule of the matrix is if the order is greater than rank, then we equate this matrix with the 0. Now for our better understanding, we solve one example to how to convert the given matrix into the normal form. So in this matrix our first work is done while giving a11 is equal to 1. So now the second rule for the applying, we convert the first row and the first column, bring all the elements are in 0. So for that we apply the operations. Always remember, once we convert a11 into a 1, then the second step convert all the first column below the a11 converted into a 0. For that we performing the operation R2 minus 2R1. When we perform this operation 2 minus 2 into 1 2, we get the output is 0, which is our requirement. So one operation we perform this. Second operation is R3 minus 3R1 and R4 minus 6R1. So the R2 row is 2 4 3 2 and minus 2r1 means we multiply the first row with 2 and write here 2, 2 2s are 4, 3 2s are 6, 1 2s are 2. So the answer of the R2 is now 0 0 minus 3, because 3 minus 6 is minus 3 and 0. So first row as it is, because we not perform any operation for the R1. So R1 we write as it is 1 2 3 1, and the second row now 0 0 minus 3 0. For the R3 we perform the operation. First write R3 as it is 3 2 1 3 and multiply R1 with 3. So 3 6 9 3. When we subtract we get the answer 0 minus 4 minus 8 0. So now the R3 is 0 minus 4 minus 8 0. And R4, for the R4 write R4 as it is 6 6 7 6, multiply R1 with 6, so minus 6 12 18 6. So the answer 0 minus 6 minus 11 0. Now the R4 is 0 minus 6 minus 11 0. So first step, a1 were converted into a 1. The below of the all the a11 column converted into a 0. Now the second step, convert all the first row except a11 into a 0. For that we perform the operation c2 minus 2c1, c3 minus 3c1, c4 minus c1. And one secret I share with you to reduce your hard work. By performing this column operation we get the answer of the matrix is 1 0 0. First write as it is all the first row except a11 write 0 0, and the remaining all the elements write as it is. No effect of the operation on the remaining elements. Why I tell you? Because listen, c2 is 2 minus 2 is 0, so the answer is 0. Now the second element of c2 is 0, so 0 minus 0 again 0, so 0 we write as it is. Then the third element of the c2 is minus 4, so the minus 4 minus 2 into 0 0, so the answer is as it is minus 6 minus 2 into c1 means 0 0, so minus 6 minus 0, again the answer is 6. In the same way c3 also, 3 minus 3 0 minus 3 into minus 3 minus 3 into c1 means 3 into 0 0. The answer is again as it is c3. So in the same way, no effect on the remaining the element. So in this way, if you follow the steps, means when first convert a11 into 1, then the remaining all the elements of the column converted into 0, then you directly write the operations for the column and converted all the first row and remaining all the elements as it is. Now for the converting the given matrix into the identity matrix, we want the second diagonal elements. We not convert 0 into a 1. For that we want here a numerical value. So again we have two possibilities. One, interchange two row, or interchange two column. We interchange two row. So we perform R2 interchange with R3. So the matrix is 1 0 0 0 0 0 0. Now the R2 is -4 -8 0, R3 0 -3 0, and fourth row stay as it. So now to convert the second diagonal element into a 1, for that we perform the operation. We divide the whole R2 with the -4. So 1 upon -4 R2. When we perform the operation, we get automatically here 1. So now the matrix is 1 0 0 0 0, -4 divided by -4 1, -8 divided by -4 2 0, and remaining all the rows as it is. Now our second target is completed. We get second diagonal element is 1. Now we want the first column below the diagonal element is 0, and the first row except a11 we want 0. So again we perform the all these steps. For that we perform the operation plus 6 R2. If we perform this operation, means R4 minus 6 plus 6 into 1 6, so -6 plus 6, we get the 0 answer. So the R4 is given 0 -6 -11 0, and we multiply second row with 6, so 0 6 12 0 R4, and this is a R2. When we add them, then the answer is 0 0 1 0. So now the matrix is 1 0 0 0 0 1 2 0 0 0 -3 0, and the R4 is now 0 0 1 0. So below the diagonal element, our all the elements are the 0. Now we perform the column operation. For converting, the remaining columns are the 0. For that, C2 minus 2C1, and we apply the same logic here. First we write all the first row as it is, then 0 1 0, directly write column 0 0, then 0 0, and the remaining all the elements write as it is, -3 0 0 0 1 0. Now I hope you all have an idea to how to convert the given element into a normal form. Now we check the third diagonal element is our 1 or not. So here the third diagonal elements are not a 1, then for that we have performed the operation R4 interchange with R3. If we perform this operation, means we interchange R4 and R3, we directly get our diagonal element is a 1. So we perform the operation Now again we want below the diagonal element we want 0, so for that we perform the operation r4 plus 3r3. Now the matrix is 1 0 0 0 0 1 0 0 0 0 1 0 and 3 minus 3 plus 3 is 0, so here all the elements are 0. So now look, this all the column is 0 and the below all the row is 0, so the A matrix is the form of I3 because the non-zero row is 1 2 3, I3 0 0 0, and this is the normal form. And the rank of A is 3 because the non-zero rows are the 3 in the given matrix. I hope you all have an idea to how to convert the given matrix into the normal form. I hope you all get the steps in your mind how to convert the given matrix into a normal form. In short, we repeat again. Convert all the diagonal elements means A11, A12, A33, A44, all the diagonal elements converted into 1 and all the remaining elements of the matrix converted into a 0 as that like. So for that, first convert all the elements below the diagonal element converted into a 0. Then second step, convert all the sides element of the diagonal element converted into a 0. If we follow the steps, you get the answer in a short time. Otherwise you get the answer but it takes long time. These are the two examples for your practice and the answer is given also, so please try. Now I hope you all have a get idea to how to convert the matrix into the normal form. Thank you.